Hello. In this video we're going to look at how to write hypotheses for two population proportions. Now, we assume when we're dealing with two populations, regardless of whether it's a yes-no trait or a numerical trait, we assume that for the null, the two populations have the trait at the same rate. So in our case here, for the null, right, we assume the proportion of people in population 1 that have the trait is the same as the proportion of people from population 2 that have the trait. And so the alternative can be, perhaps, let's say, P1 is greater than P2, something like that. And remember, we could have written this in a different order. We could have said P2 equals P1. It says the same thing. Or that P2 is less than P1. These two say the same thing, it's just written in a different order. And also using algebra, since we have an equation, so I'm working with this again, as long as I subtract the same quantity from both sides, I have really the same thing. So now what I'm saying is the difference between the two population proportions is 0. And the same thing is true with the inequality. As long as I subtract the same thing from both sides, right, then I really have preserved the same solution set. So, although I wrote it this way, I could have written it P sub 1 minus P sub 2 is 0. And for the alternative, P sub 1 minus P sub 2 is greater than 0. Right? So that would be here. And then also, doing the same thing, I could have just used algebra, and I could have gotten P2 minus P1 equals 0 versus P2 minus P1 is less than 0. Okay? So all of these four forms are really saying the same thing. This, and this all say exactly the same thing. Okay? It's really a matter of preference and how you want to write it. So let's go through some specific examples. So in these examples, these are the examples that we labeled. So here the trait was whether someone traveled abroad in the past year. And we looked across two different populations, people who were a little older, aged 40 to 75, versus people who were a little younger, people aged 18 to 39. So I let this be older and younger. So now what they ask is, test the claim that a greater percentage of people who are 40 to 75, so a greater percentage of people who are older, had the trait, traveled abroad in the past year, than the people who were younger. So piece of older greater than piece of younger. Now, if I were to write my hypotheses then, remember 4 different forms that I could have. Piece of O is the same as piece of Y. Piece of O is greater than piece of Y. And then if I change the order in which I write those, I could have put Y first and then O. Alright, in that case, the alligator mouth is eating the O, so you're going to have the same thing here, right? Piece of O is greater than piece of Y. And again, if you just change, and then if you subtract, using algebra, you subtract the same quantity from both sides, you would have that the difference is 0, or that the difference is positive. And the only way you could get a positive difference is if the first quantity is larger than the second. And again, just rewriting the order. Oops, so Y and O. Like that. Sorry about that. That's Y and that's O. So here you're saying the two, oh, and this should be a difference. Oh, sorry about that. So you're saying that the difference is 0 because the two population proportions are the same, or that the difference is negative because the first quantity is smaller than the second. All right? So that's example 1. Here's example 2, and what you could do is pause the video and see what you would get. All right. So what we saw in the previous video is that the trait is whether you choose to have a cat as a pet, and then we're looking across the two populations, males and females. Now specifically here, the claim is asking for you to test, the test is the claim that fewer males choose to have a cat as a pet than females. So you have P sub m less than P sub f. And I say sub because it's a subscript, right? So again, your null and your alternative. You'd have P sub m equals P sub f, or P sub m is less than P sub f. So here what you're saying is the proportion of males that choose to have a cat is the same as the proportion of females that choose to have a cat as a pet, versus the proportion of males who have a cat is less than the proportion of females that have a cat. Again, you can change the order in which you write this. Let's see here. Right? So here, females are greater, here, females are greater. And now, of course, you could use algebra to write these as differences. So P sub m minus P sub f is 0. P sub m minus P sub f is negative, is less than 0. Or here, P sub f minus P sub m, 0. P sub f minus P sub m greater than 0. All right? And the last example then, and the trait was whether you're a climate change believer or not. Right? And you're looking across two populations, 2000 and 2010. Specifically, they're asking to test the claim, is there a significant difference? So difference is when you have a not equal to in your alternative. Right? So that could be something like P of 2000 is different from P of 2010. Right? So let's go ahead and set up our 4 possible hypotheses. And of course, you only have to choose one of these. I'm showing you all your possible options so that you know what's available to you. Okay. So here you could say P sub 2000 is equal to P sub 2010. P sub 2000 is different from P sub 2010. You could have written this in a different order. Okay. And then using algebra, you could subtract and find differences. Okay. And here, oops, sorry, that's a difference. It is different from 0. All right. Now, what you're saying here when you write this is you're saying the two population proportions are the same or they're different. And that's true for each one of these. So all these 4 formats, they're written in a different form, but they all say the same thing. All right? Thank you so much for listening.